Oh, hi. Monaco is here. And Milks
Oh
is
yeah,
there.
I'm behind the camera.
We are going to give you a quick background, purpose, procedure on our acid base indicators and pH lab. On your front paper, you've got yourself a nice table M. And the background information I'd like you to record. Background says that indicators change color in different pH solutions. You've seen this a ton in living environment and other scenarios where you've used these indicators. So that's kind of a dot. The new thing is that a color change is called an endpoint. So when you see your indicator change from red to yellow, you know you've reached the end point for this neutralization that we're calling it. Now, a pH probe can be used to measure the pH value at the end point. So we're relating the color change of the indicator to the pH that occurs at this point. And we've noticed that we have some limitations here. Our techniques and our technology is brute force style. So if you're looking at table M pH indicator range, you're going to see 0.4, we're going to actually see your endpoint probably beyond that spot. But that's okay.
For today.
For today. This isn't a titration, so it's not a perfect neutralization. We have that set up for the next lab where technique really does matter. So we're doing brute force, relating color change to pH at the endpoint. So the purpose that I want you to see is that I really need you to see how the pH indicator colors change and relate these to the pH of the solution. So we're gonna test the pH after we've reached the endpoint and just see where you fall on the pH scale.
Really just to verify that we went past the point.
Right.
Right?
Because table M is not one of those kind of reference tables that you might just naturally figure out how to use on the fly.
Right.
You got to be taught how to do it. Now, for your procedure, I better not see this written there, because I want to see a nice listed, bulleted form showing a well-detailed procedure after you've watched me do this particular example, first sample on this lab. So do the setup and tell what you do. I want it so that a freshman who's never taken chemistry or anything like that could do what I'm doing. Step one.
By reading the words that you wrote.
Step one, step two, step three, exactly. Just put that thing in that thing, not good enough. So turn down the music, turn up the Monaco, and write your procedure. This might take a little while after you see what I do. But
Might have to watch it more than once.
you should really know what you're doing before you step foot in my lab when you do this.
All right, here we go.
So,
Moseying on over to the lab.
we have two sets of indicators, okay? One's in the crate, I've already pulled one out. Get a piece of paper, cut it down to size, put it underneath,
They are all labeled. Check it out.
put it underneath your 50 ml beakers. Make sure your beakers are nice and clean. The first one you want to test is methyl orange, so kind of put it close by. Second one, bromothymol blue. It's in the list of your data in the lab. Third one, phenolphthalein. Fourth one, litmus. Fifth one, brome cresol green. Make sure those labels stay on. Now, don't do these one at a time. Set them all up so you can do all 5 in a row so that this takes less time.
Sweet. How much acid goes in each, Mr. Monaco?
Well, 10 milliliters. The acid will be prepared for you. You should get a beaker, label it acid, put a pipette in it, measure out your acid. I had a little too much in here. Bottom of the meniscus, boom. 10 milliliters, ding. And I'll put it right in there. Okay? I did that 5 times. So I have 5 10 mil samples of acid.
Okay. Now what do we got to do?
We got to add our indicator. Now,
Add
each
indicator.
indicator requires a slightly different amount.
Uh-oh, we better pay attention.
Better pay attention. Methyl orange, use 2
1, 2.
drops. Then give it a nice swirl.
Mister.
Put that in right on top.
Oh,
See?
okay.
You want a nice uniform color, and the white background helps us out.
And then check it.
Can't really tell what's going on.
The color is harder to see.
That's why we put it on the white paper.
Oh, looky!
Oh, it's to make a sense. So, the next one for bromothymol blue, you got to put 5 drops in.
1, 2, 3, 4, 5. I'm the counter guy.
And then give it a swirl. It's not homogeneous yet. Now it is. Notice this is a very light yellow.
But
so these color
see
changes are subtle.
I see colors. Though.
You're
Look,
looking
it's-
for-
look, I see colors. Okay,
If you're
good.
looking for Crayola colors, you're not going to see them every time. Phenolphthalein, it's colorless at first. You only need 1 drop. It's colorless, but doesn't mean you shouldn't swirl it and mix it anyways. Got it? Litmus, notoriously weak color change. So you got to add a bunch of this. 10 drops, DAs. 1, 2, 3, 4, 5, 6, 9, 10. 10 drops. Yes, notice, very weak, subtle color change. This is technically considered red on our reference table. To me, it looks more like peach, but they call it red on table M. Brome Crisol green, 5 drops of this. 1, 2, 3, 4, 5.
You do count. You do count very well.
I have a very young son at home. He loves the count. Okay.
All right, now, Mister, I got a bunch of colored solutions.
Now
I'm
what do I-
done.
No, you don't. You don't. You haven't done anything except add an indicator to the acid. And so,
what are we going to indicate?
a change in color. An endpoint is what we're looking for.
Right, which equates to a change in pH.
So you have to take, this is acid, you got to take some base, which we've standardized, we prepared for you, and you have to add it in as you go. I'm only going to do one of these to show you how to test it. So you get a full pipette there and you got to go slow, 1 drop at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Swirl every now and then. It's not about counting drops. I'm just doing that because I know when we get close. Notice, I don't know, there's a little oranginess coming.
Yeah, it almost shows up on the...
Swirl every few drops. 1, 2.
Okay, now swirl every drop.
Now we'll start swirling every drop. If you can see,
Once you start to see that orange that doesn't show up as good on the camera, once you start to see a little bit of a color change but goes away when you swirl, this is when we got to start going slow.
see there, you
Ooh, I can see a little bit more orange.
Camera's starting to pick it up. Doot, 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 doot. All of a sudden, you'll hit the end point, and the
Yeah, he's adding like 3
Indicator.
and 4 drops at a time now.
indicator will just like whoosh. See its
Whoa.
colors sticking around and staying around a little longer.
Okay, so it's 1 drop now in a swirl.
A
One
drop
Ooh, look, I see yellow.
and a swirl. That's the end point of your titration. You got to the point where the color changed.
Okay.
So
Now
you
what do we
take
do?
the last little bit. You take this pH probe. Okay. This one, the tap water's a little acidic. Typical.
Almost 7.
Typical. You're gonna notice how it's stored in water. You got to put it in and out of this water. Don't let these sit around on the table. They need to be wet in order to work. So you stick it in there, and you
Ooh.
test and see. We did really good on this one. We were
Yeah.
close to the range. So 5.3.
Right, now we'll see on the reference table that this has a range of up to 4.4. But so we're just proving that we are past that 4.4.
And 5.3.
That makes sense.
Mister, it's changing constantly.
Yes.
Yes, it is. Go to 1 decimal place, okay? 5.1, all right? And it's not about getting it to sit still.
No. So what are we going to do with that data real quick?
What am I going to do with that data? Well, I'm going to go to my data chart. And that was methyl orange. And so I knew at about 5.1, I put a star. That's my end point that I observed.
Okay. Now I'm okay if this star is above, below, or on the chart.
Doesn't really matter. You got to notify us where your endpoint was for methyl orange.
Correct.
And in your analysis, what you're going to do...
We're gonna repeat this for every one of these though, right?
Oh, yeah, right. I'm
So-
getting ahead of myself.
Yep, that's
You're
right. So let's.
You're right.
We're gonna go through and do that base now for each of these until we get the color change.
Yo, Mr. Drop the Bass! Whoa! What am I doing wrong right now, Mr. Milks?
You're throwing so much in that you're just not even paying attention.
Because I don't want you all to get answers just by watching this video. I want you to actually do it. Notice there's color changes happen. and blasted past all those endpoints.
That's not what I'm looking for.
No, we wanted to go carefully, nice and neat, do what we did on the first one, and check that endpoint with the pH probe. I'm not putting this in there because I don't want you to
We
see those.
blew way past all those.
On purpose to prove to you that they will change color. Now, to show you some analysis, to pick it up, clean it up, you go back to the table M chart, you look at your compound, or your indicator, and you see that the pH was from 0 to 3.1, it's gotta be red,
Because the left-hand side is
the left-hand color.
correct.
Now from 4.4 onwards, it's yellow.
All right,
so
so-
I'm gonna go to my chart. So from 0, was it 3.1? I'm gonna color in red for my methyl orange.
Okay.
And then it was 4.4 onwards was yellow. And you can see that your endpoint was in that yellow zone. Mr. Milks, what should I do for this little area there that was so hard for the camera to pick up?
If I mix red and yellow together, I'm going to get oranjo.
Naranja. Naranja?
It starts with an N or an A.
Orange. Okay, so that's difficult to see. Some of these indicators you'll see a little bit better than others, the transition between one color and the next, but usually it's a mix of the two. It's never anything
Oh,
else.
and look, it's called
Methyl orange. So that was a coincidence. Bromethymol blue won't necessarily be blue in the middle.
No, and phenolphthalein doesn't have any color in it at all. No,
The name.
the bromothiamyl blues are usually because the indicator itself is blue.
Mm-hmm.
But two of them have the color of the range.
And so for your last little bit here, your analysis, it asks you a few questions. Which indicator would be best to show an endpoint around neutral pH? Look at your scales, look at your table M, and decide which one would be best around neutral.
Okay.
And then the last little bit is we're going to take the pH reading at your endpoint. So for me, in this first scenario, yours is going to be slightly different. It was 5.1.
Okay.
I'm going to do the mathematics that relate that pH back to the concentration of the acid itself at this point, using a logarithm. So I'm going to do 10 to the negative 5.1, it'll tell me the concentration here. So if I go 10 raised to the negative 5.1 on my calculator, it's going to give me the answer here.
Okay.
Because negative log of our H plus concentration is your pH. So we have our pH, we're kind of working a backwards algebra.
Yeah. But this number's not negative.
No, that number is not, in fact, negative. That was my pH reading. But I make it negative when I plug it into my logarithm, or my inverse log,
Correct.
to get my concentration in molarity.
Okay. So no CEI in this lab.
No, because this is about you seeing the color changes so you know how to use your indicator on the next lab and relating those color changes to the pH using a pH probe. So
Okey-dokey.
anything else to add, Mr. Milks?
No, I think we pretty much covered it. We want you to go slow.
Yep.
We're not, at least when we're adding the base. The rest of it is streamlined. If you saw, we add all the acid first. We add all the indicators first. Then we go through and do the base, and then slowly swirling when we start to see a color change, right?
Yep.
And then I am under the impression that you can pH them all at the same time too.
At the very end.
But
right?
here's the key. If I'm going to go ahead and pH this guy,
you gotta clean it off in between.
you gotta rinse it.
well.
And you want to see this go back to the
Almost
around the,
about 7.
yeah, the number you was at. If it was 6.6, you wanted to go back to 6.6
And then replace that with fresh water.
when you're done.
When you're done.
Please.
And you'll turn it off. They're okay to sit in there because I mentioned they have to remain wet in order to function
Right.
properly.
And I'm sure we're going to have a nice big waste beaker for these guys. You put them all in the waste beaker together, rinse out your glassware, and put the glassware back.
Look at the pretty rainbow. If you're good and you really understand this and you work through this unit quick, I would love to see somebody step up to the plate and make a red, orange, yellow, green, blue, indigo, and violet. I want a chemistry rainbow if you can hack it, but you got to do the basics.
You've just been challenged.
Challenge
See ya.
accepted.
See ya.